All right, guys, so this is the part two of the video. This is on inscribed figures. So an inscribed figure is a figure that is placed inside of another figure so that it fits exactly. So you're typically going to see the shape that you see here with the circle and the square. You might see like a square inside of a circle, or you might see triangles inside. There's a lot of different things, but basically, when you're looking at shaded regions, you're talking typically about an inscribed figure. For some of you that did the circle art for your project, this is essentially an inscribed figure, although yours didn't all touch. It is talking about the same thing. So if we take a look, the directions here are find the area of the shaded region. You're going to find the area of each figure. So you have to figure out what are the figures that are inside each other, and then you're actually going to subtract. So in the composite figures, you're adding them together, but when it's talking about shaded regions, you're actually going to subtract. So here we have a 6 by 6 square, and then we have a circle. So the first thing I did was I established my diameter. So I have the diameter that goes all the way across my circle. So that makes my radius 3 meters. And I think it's very important to establish what is your radius, because we're going to have to find the area of that circle. So if you take a look here, I did the area of the square. Area of a square is base times height. So we did 6 times 6, which is 36 meters squared. Secondly, then, we took the area of the circle. So we're going to find the area of the circle, which is pi times radius times radius. And in this case, my radius is 3. So 3 times pi gives me 28.26 meters squared. And then because it's a shaded region, you're actually going to subtract the area of the square from the area of the circle, because you want to know what are these little pieces right here that are on the outside of the object. So you're going to take 36 and you're going to subtract the 28.26, and you're going to end up with 7.74 meters squared. And that represents what these little shaded regions are off to the side. So let's take a look at another example. So this one is 8 centimeters. It says find the area of the shaded region. So we're going to assume that this is a square because it didn't give us any other information, and there's really nothing else that we can tell from that. So we're going to subtract to figure out what those other pieces are on the square. So I encourage you right now to stop your video and try to solve this yourself using what we had talked about in the previous slide. All right, let's check your answers. So the first thing you would want to do is you want to establish what that diameter is, or what that radius is. So halfway across, if the entire thing is 8, that means this part right here is 4 centimeters. So my area of a circle is pi times radius. So I had pi times 4, which gives me 50.24 centimeters squared. Then I need to find the area of the rectangle. So area of the rectangle is area is equal to 8 times 8, which is 64. And then finally, because this is the shaded region, we're going to subtract to figure out the area of the rectangle minus the area of the circle, which is 13.76 centimeters squared. And that's talking about this information that is this shaded region of the circle. Now, we can have something like this, a square inside of a square, or a rectangle inside of a rectangle. These are squares because this is a 10 by 10, and this is a 7 by 7. Now, these little tick marks here mean congruent. So since all the two ticks are those are all 7. All these little guys here mean that they're all the same, and since this whole thing is 10, that means that whole thing is 10. So let's take a look here. Square number 1, base times height, is 10 times 10, which is going to give us 100 millimeters squared. The second square has a base and a height of 7, so we have 7 times 7, which is 49 millimeters squared. So then finally what we're going to do is we're going to subtract square 1 from square 2, and that's going to give us the area of the shaded region. So we have 100 minus 49, which is going to give us 51 millimeters squared, and that's this information outside of those in the shaded region. Let's take a look at something like this. We have a parallelogram with a circle. So this one's a little bit different, but same concept. It's asking for what is the shaded region. So you're going to find the area of both figures, and then we're going to subtract them. So the area of the parallelogram, we have base times height. Okay, and in this case, the base times height, we have 6 times 13. So 13 is all the way across, 6 is all the way up. So we have 6 times 13. That gives us 78 centimeters squared. The area of the circle, we have pi times radius. And in this case, since the entire thing is 6, the radius would be half of that. So from the center of the circle out, so it's going to be 3. So we have area is equal to pi times 3, which is going to give us area is equal to 28.26 centimeters squared. And again, because it was telling us to find the shaded region, we're going to subtract those. Okay, so we take the area of the parallelogram, which was the bigger area. We subtract what was inside, which is a circle. That's going to give us the area of the shaded region. So 78 minus 28.26 is 49.74 centimeters squared. Let's take a look at this one. So this one's very similar, but it does have a little bit of difference in it because it is a triangle. So the biggest thing with triangles is to remember that the two shorter sides are always your base and your height. The longest side is never the base or the height of the triangle. So when you're looking at this, okay, we have two different figures. We have a circle, we have a triangle inside. So from the center of the circle out is my radius. So if this entire thing is 10, that means this radius is 5. So if I'm finding the area of the circle, I would have pi times radius times radius. So we have pi times 5 times 5, which is 25 times pi, which gives us 78.5 meters squared. The next thing then is those legs of the triangle. So remember the two shorter sides are my base and my height. It really doesn't matter which one is which. So the area of the triangle, we have 1/2 base times height. So the base and the height are 6 times 8. We're going to half that. So 6 times 8 is 48. Take half of that, you have 24. Finally, the last thing you're going to do, you can find the area of the circle minus the area of the triangle, which gives you the area of the shaded region. So we have 78.5 minus the 24, which is going to give us 54 meters squared. All right, so here is our last slide. This is a real-world example of how to do where is shaded region and something that we would do in real life. So this would be like an architect doing a design or a contractor doing a design for a fire pit. So there is a brick patio around a fire pit. So here's your fire pit, here's your brick patio. So it's really wanting to know how much brick or how much surface area is covering in that example. So here's what we're going to do. We're going to find the area of the fire pit. We're going to find the area of the total, which is the fire pit and the brick patio, and then we're going to subtract the two. And then obviously we want to make sure we label our answer at the end. So let's take a look at this. The area of the fire pit the radius is 1 because this entire thing across is 2. So just half of that is going to be 1. So we would have pi times 1 times 1, which is going to give us 3.14 feet squared. Then we're going to find the area of the larger circle that includes that brick patio. So this entire circle. So now we're talking about this 1 foot here and then this 5 feet from here to here. So if it doesn't point and show all the way in, it definitely only goes to the edge. So we have 1 foot here, 5 foot here, which gives us 6 feet. So the radius is 6, 1 foot of the patio, 5 foot at the end of the other circle. So we have pi times 6 times 6. So 36 times pi gives me 113.04 feet squared. Now, the area of the brick patio is minus the area of the fire pit to take away this part of the brick patio that we don't need because we're not going to put bricks in the fire pit. So we're going to have 113.04, we're going to subtract 3.14, and that's going to give us 109.9 feet squared. So that's just a little way of how that might be used in real life. All right, thanks guys for watching the video. I appreciate you guys taking notes. Again, remember, if you have any questions, email. And again, if you have any questions, you can always rewatch these videos. The slides are also available if you don't want to hear my annoying voice. And then hopefully this will kind of sink in with this and then having the Ed puzzle. All right, good night, guys.